Section 8.3 on bouncing is 7.3 in your textbook. Bouncing is not just stopping an object. So if you have motion of an object moving towards you and you catch it and you reduce its speed down to 0, then you've changed its momentum. So changing its momentum takes force, and the longer the time that you can catch that object, the less force it takes. Well, if you want to reverse its direction, so not only just catch it and bring it down to 0, but then also send it backwards away from you. Okay, so you catch a ball and then throw it back, or you are playing volleyball and it comes at you and then you bounce it off of your hands or off of your fists back across the net. It takes more force to bounce it away from you than it does to catch it and stop it. And that is what this section is on. It's on bouncing. So they give an example here. If you catch a falling flower pot, I guess, with your hands, you provide an impulse. Remember, force times time is equal to an impulse. Force times time is an impulse. An impulse is equal to a change in momentum. Okay, so this is equal to a change in momentum. Both of these would be momentum. So an impulse is a change in momentum. Well, an impulse is force times time. So the longer that you can catch that force or exert that force, whether it's a slowing down force or a speeding up force, the less force, the longer that you do it, the less the force would have to be itself. Okay, because it's a product of the force times the time. So if you were to catch a flower pot and reduce its momentum to 0, but then throw it back up again, you can imagine that it would take a force to stop it and then a new force to propel it. So if something bounces, it takes way more force to stop it down to 0 and then send it back up again than it would if it were just to go down to 0. So if you were to have a basketball and that basketball hits the ground and then changes shape, deflects, flattens on one side. Okay, so it's stopping it because it was going in one direction and it stops it down to 0, and then the deflected shape of the ball then restores because of what the ball is made up of and the air it's in it, and it will go back off of the ground and you bounce it off of the floor. Well, it takes more force, more impulse to send it back again than if you were just to stop it. So if the flower pot falls onto your head, okay, well, it depends on the amount of damage it could do to your head would depend on whether it bounces or not. So if you just reduce it down to 0 and it falls on your head and stops, it's going to take a certain amount of force depending on how long it takes to catch that on your head. Like if you don't know it's coming and you're not moving to try to make it longer, well, it could do a lot of damage. But if it bounces off your head, it's going to do a lot more damage because the force required is more to stop it and then to send it out again. It would be almost like two different actions, one stopping it and then new force required to propel it away from you. I don't know if you've ever seen anyone break bricks, but the way they break them is to bounce their hand. If you can bounce your hand rather than send your hand into something, then at least twice the amount of impulse is put on it, and that impulse then is enough possibly to break something like a cinder block. Back in the 1800s, when everybody used water wheels to operate industry, a fella came up with a pretty cool design of a curved water wheel so that the water would come in and then be forced to turn around and come back out. And by doing that, the water was essentially bouncing. And since the water was bouncing, it was exerting more impulse than if the water was simply to fall onto the water wheel. So the same amount of water, they didn't change the water, the same amount of water was getting more pull or more push on the wheel just because of the design of the wheel. It made it bounce rather than just make it hit. So the water would come in, the water would turn, and as it was turning, the impulse would move into the water wheel, and you'd end up with more of a movement than you would have otherwise had. So how does the impulse of a bounce compare to stopping only? Well, it can be up to twice. The impulse can be up to twice the change in momentum as just stopping it, because you've got a mass times a velocity coming in at you, where a velocity, remember, is a force that has a direction to it, and it's coming, say, to the right, and you hit the tennis ball with your racket and send it away towards the left. Well, that bouncing ball took twice the impact than if just catching it. So if you were just catching a ball, it would take one amount of force. If you catch the ball and bounce it away from you, it's going to be twice. So if you have a basketball that was flat and hits the ground and stops, it's going to poke the ground at a certain amount. But if it were to have a full basketball and it bounces off the floor, it's going to be twice the amount of punch onto the floor as if it were just to stop.